Good day everyone, I am Deck Cadet Sonia Candisley from Group 2 and we are going to report about the relative plot. So, relative plot is defined as a polar representation of the successive positions of one or more moving objects with respect to a reference position. This reference position will normally be your own vessel, the bearings and the ranges that are taken from your radar. When we plot the relative plot into a maneuvering board, the letter E that represents your own vessel must be placed in the center. Any maneuvering ship that is near from your position is labeled as M1 and M2. DRM or direction of relative motion, it is the motion of your own ship relative to the motion of the another ship. MRM, that stands for measure of relative motion, it is a measure from your own ship to the relative motion of the another ship. SRM stands for the speed of relative motion. CPA, or the closest point of approach, it is an estimated point in which the distance between the own ship and another object target will reach the minimum value. CPA is an essential factor of the ship's safety, especially when the ship is avoiding the collision.
Good day, sir. This is Cadet Chopin, and I'm the second reporter, and I'm gonna report about closest point of approach. So, what is closest point of approach, or CPA? So, in radar plotting, CPA is an estimated point in which the distance between the own ship and another target or object that will reach the minimum value. So, the estimation of CPA is used to evaluate the risk of collision between your ship into a target or an object. So, what CPA is made of? So, CPA is made up of three parts. First is the range or the distance CPA. So, distance CPA is the distance in which the ships are close to each other. The second is the bearing. And the third is time CPA or TCPA. So, TCPA is the time until the closest point of approach of two vessels. Why do we need to know CPA or the closest point of approach? So, in knowing CPA, we may able to evaluate the risk of collision and most possible to avoid it. So, in setting up your maneuvering board, you need to plot yourself at the center, of course, of the maneuvering board. Then plot your ship's course, speed, and distance. So, for example, you are on a course of 050 degrees true and a speed of 15 knots. So, in the maneuvering board, you can see on the left, the distance scale, and on the right is the speed scale. So, using your compass divider and triangular ruler, you can plot yourself on the maneuvering board. So, in determining CPA, the next reporter will explain that to you. Thank you.
Good day everyone, I am Cadet Asis John Joshua. So, I'm here for the continuation of the reporting. So, in radar plotting, we aim to get all the information of RPAC can give. So, these information are CPA, TCPA, and course and speed of the target. So, when we see the target on the radar, we take the range and bearing of the target and note down the time of observation. This is the radar plotting sheets look like. Let us say we noted the following bearing and range at 800 hours. So, you see the graph. And then, let us plot this out of the radar plotting sheet. So, we go back to the radar plotting sheet. As you can see, there's a mark in here. We plot the graph and then after some interval, take the second and third. So we proceed. Now we got assuming that we got this time interval, and then the range and bearings. Plot this on the radar plotting sheet. The first target, and then the time interval, the second time interval, and the third time interval. So, the third time interval, we name it as A. This is the line of the relative approach of the target towards the vessel, which we assume at the center of the sheet. Now, for the CPA, we need to find the closest point of the time approach to the center. So as you can see by the graph, so this is the closest point or line in the center, closest to the center. So that is our CPA, closest point of approach. So all we need to do is to measure this one by using the plotting sheet scale, and after that we get 0.8 nautical miles. And to calculate TCPA, we just need to calculate the time acquired to reach at the point at C, considering it took 12 minutes to cover the distance of OA. So as you can see, from O to target A, it travels 12 minutes, and their range is 2 nautical miles. So in getting to TCPA, you need that given. So 2 nautical miles cover in 12 minutes, and assuming that getting this CA from closest point of approach to last target, which is A, this one, you need to measure this one using by a ruler and put it and scale it in here. So you get 5.8 nautical miles. So in getting the TCPA, so the time closest point of approach is 12 minutes times 5.8 nautical miles divided by 2, and the answer is 34.8 or 35 minutes. That's all, guys. I hope you learned my discussion.